Let's dive right into this explainer because today we are doing something totally different. We are finding the back door into every complex question. You need to work smarter, not harder. Welcome to the ultimate strategy session for mastering complex vector geometry problems for the Cambridge 0606 exam. Now, this strategy isn't just for 0606. If you are sitting for 0580, 4024, 4037, or 4040, the core principles we are about to unpack are your absolute secret weapon. Imagine this. You're sitting in the exam hall, the clock is ticking down. You flip the page and boom, you're hit with a massive, terrifying vector geometry diagram that looks more like a spider web than a math problem. Most candidates completely freeze. To show you why, let me introduce you to two very typical students. First, we have Alex. Alex overloads his answers with raw mathematical facts. He memorizes every single formula, but he provides absolutely zero analysis. Then we have Sam. Sam rushes. Sam looks at the diagram, panics, races to the finish line, and completely misses the command word requirements. When you look at their past papers, it is just a sea of red pen marks. Flawed answers everywhere. Today, we are going to fix that. We are going straight into the examiner reports to show you exactly how to secure those top marks. So this is the ultimate question we need to address right out of the gate. Why do multi-stage vector problems consistently destroy top grades? Seriously, principal examiner reports reveal that this is actually one of the most misunderstood areas in the entire syllabus. It is the exact point where even highly capable candidates, students who have been getting A's all year, suddenly hit a brick wall, lose their footing, and bleed points. But why does this happen? Well, it's not because the fundamental math is impossible. The math itself is usually just addition, subtraction, and some basic algebra. The real issue is how students handle the complexity of the command words. Look at Sam. Sam sees a question that says, hence, show that. But Sam ignores the word hence, tries to start from scratch, and gets 0 marks. Look at Alex. Alex sees a complex shape and just starts listing every vector property of a trapezium without actually answering the specific prompt. They both fail to decode the command words. The examiners are setting a trap. And if you don't know the backdoor strategy, you are going to fall right in. Here is our exact flight path for today's explainer. First, we'll uncover the vector geometry trap. Second, we will reveal the method mark strategy. Third, we are going to lay out the 5-step blueprint. Fourth, we'll look at the top 3 examiner warnings. And finally, we will wrap up with mastering cross-topic connections. Let's move straight into section 1, the vector geometry trap. Students consistently struggle with multi-stage analysis, completely missing out on crucial marks because they focus only on the final answer. When presented with a complex diagram, the natural human instinct is to rush towards the finish line. You want to find that final vector, write it down in the little box at the bottom of the page and move on to the next question. But listen to me carefully. Cambridge examiners are testing your logical, structured reasoning. They are testing how you handle causal relationships within the geometry. If you jump straight to the end without showing the framework of your thought process, you fall right into the trap. You become Sam. You do all the mental math in your head, write down a final vector, make a tiny sign error, and walk away with 0 marks. 0 out of 5 possible marks, because you didn't show the multi-stage analysis. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's unlock section 2, the method mark strategy. This is where we start hacking the system. This definition right here is vital. The method mark strategy is all about earning marks by explicitly showing the systematic process and analytical framework used to solve a problem. Examiners actively look for your evidence-based reasoning, not just a magic number at the end. Think of it this way. The examiner wants to see your mathematical architecture. They want to see you apply established principles systematically. This is where we introduce the Peel framework to mathematics. Yes, you heard me right, Peel. Usually that's for English or history, right? Point, evidence, explanation, link. But top students use a version of this for their math answers. Point, state the vector relationship. Evidence, reference the specific points on the complex diagram. Explanation, show the vector addition or subtraction explicitly. Link, connect it to the final requested vector format. If you structure your answers like this, even if you make a tiny arithmetic error right at the very end, your structural reasoning is perfectly laid out on the page, and you're still going to secure the majority of those method marks. You are literally hacking the mark scheme. Moving on to section 3, the 5-step blueprint. Let's build your exact system. This procedural framework guarantees those method marks. By following this standardized 5-step sequence, you systematically process the complex diagram without getting overwhelmed. Step 1. Deconstruct the question. Decode the command words. Does it say find, show that, or calculate? Step 2. Extract relevant data. This is where our time management matrix comes in. Scan the diagram and instantly write down the equal and parallel opposite vectors. Step 3. Select your analytical framework. Are you using vector addition to find a resultant path? Step 4. Execute with clear notation. This is absolutely non-negotiable. Step 5. Present with correct terminology. Remember Alex. Alex failed because he just threw data at the page without an analytical framework. Sam failed because he rushed past step 1 and ignored the command words. You are going to use this 5-step blueprint to build an impenetrable answer. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Welcome back. Let's hit Section 4, Top 3 Examiner Warnings. These 3 traps bleed marks especially when candidates fail to use proper formatting or ignore the specific context of the vector diagram. We are going to turn this into an interactive workshop right now. Challenge 1, data scan. Imagine a complex math chart right in front of you. You have a 60-second mental timer. You need to extract the core trend immediately. The first warning is using the wrong approach for the context, applying a rule that doesn't fit the specific geometry you just scanned. Challenge 2, find the flaw. I want you to picture a flawed sample math paragraph. It's an answer written by Alex. It lists 3 correct vector formulas but has absolutely nothing to do with the triangle on the page. That's the third warning, providing generic answers not specific to the context. And the second warning is a total tragedy, forgetting to check format in presentation. Omitting vector notation, like forgetting to underline your vectors or leaving out the arrows, means you aren't actually speaking the mathematical language. You are throwing easy marks away. You must link every single point and equation to the specific scenario given. Let's look at the ultimate transformation. We are taking Alex's generic, heavily penalized answer, crossing it out with red pen, and transforming it into a green checkmark masterpiece. If the question involves ships moving at sea with specific forces acting upon them, your vectors need to represent that exact context, rather than just reciting a generic textbook formula. Examiners frequently note that students will write down a beautiful textbook vector formula, but completely fail to apply it to the complex diagram provided. You have to contextualize your knowledge. Challenge 3, speed writing. Next time you study, set a 30-second timer and try to write one perfect peel paragraph for a vector step. Point, evidence, explanation, link. Transform your generic thoughts into a hyper-specific, contextualized answer. That is the true mathematics success blueprint. Finally, Section 5, Mastering Cross-Topic Connections. Let's elevate your grade. This table breaks down the assessment framework perfectly, showing that moving from a basic, descriptive level to an elite evaluative level requires justifying your decisions and evaluating alternatives. A lot of students stay firmly in the descriptive tier. They can identify the key vectors on a shape and maybe do a basic calculation. That's a solid C grade. Some move to the analytical tier by showing their working and reasoning clearly. That gets you into the B and A territory. But the top-scoring candidates, the ones hitting those high A stars, they reach the evaluative level. They understand how vector geometry integrates with other syllabus areas, like trigonometry or simultaneous equations. They justify exactly why they chose a specific path through the vector diagram to solve the problem, rather than just guessing. Top-scoring candidates actively demonstrate this evaluative thinking. When they look at a complex case, they question assumptions. They don't just assume 2 lines are parallel unless it's proven algebraically or given in the question. They consider different perspectives. Maybe calculating the vector from A to C is easier if you go through point D instead of point B. They identify limitations and evaluate alternative interpretations of the geometric evidence before reaching a final conclusion. This is the hacker mindset in full effect. You are analyzing the entire board before making your move. The syllabus explicitly states that top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. I absolutely love this quote because it proves that Cambridge prioritizes analytical depth over superficial breadth. The examiners aren't trying to trick you. They're trying to see if your understanding is genuinely connected. If you have mastered the conceptual framework, your systematic analysis will transfer perfectly, no matter how weird or unfamiliar the diagram looks on exam day. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Ask yourself this critical question the next time you face a complex vector geometry problem. Are you just solving the problem, or are you mastering the analytical framework? Remember the 3 rules that guarantee top marks: command word decoding, PO framework application, and the time management matrix. Mastering this entire process is the true key to exam success. Don't just chase the final number, build the evidence step by step. Here's your final reminder: subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @aceexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.